Hey guys, welcome. Yeah, so in the past I shared a really fun geometry problem called the three squares problem, and in this video I share an equally fun geometry problem called the three circles problem. And here is the three circles problem. Okay, so we've got three circles that are tangent to each other in the fashion displayed in this visual, and all three circles in turn are tangent to this black horizontal line. And the biggest circle has radius 4, the mid-sized circle has radius 2, and the task is to find the radius of this little guy. Now, it turns out that the solution simply amounts to doing Pythagorean theorem 3 times on 3 very useful triangles. And of course, I'm making it sound a little easy when I say the solution is simply doing Pythagorean theorem 3 times, because you have to be careful enough to figure out what triangles to do Pythagorean theorem on, right? Okay, so there are 3 triangles of interest, and here's the first one. Okay, now notice that since this little bit is x, this little bit is also x, and since we know that the radius of the big circle is 4, this leg of this black right triangle is 4 minus x. And then it's easy to see that the hypotenuse of the black right triangle is 4 plus x, because this little bit is x, and then this is 4. Okay, so then that means that using x, that is in terms of x, we can figure out how long this is, this horizontal distance. And this is of great importance to us to figure out how long this is in terms of x. Yeah, and of course that amounts to just doing Pythagorean theorem on this black right triangle. So let's isolate it and do just that. So the black right triangle labeled as it should be looks like this, and then doing Pythagorean theorem is going to first start like this, and I'm going to run through the algebra because this is a geometry problem. Okay, and it's fairly straightforward algebra. Okay, so we just learned that what I've called y, which is this horizontal distance, so this leg of this black right triangle, we just learned that it is equal to 4 times root x. Cool. So let's move on to the second right triangle of interest, and that would be this little guy. Yeah, cool. Now, I'm not gonna talk in detail about how to label this guy, because you should be able to follow from what I said earlier about the guy over here. Very similar reasoning will reveal that this is how we should label this little guy. And now we've called this horizontal distance z, and so then we should do Pythagorean theorem to figure out what z is in terms of x. And so then Pythagorean theorem, boom, 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 one more. Yeah? Okay, so z is the square root of 8x, which is the same as 2 root 2 times root x. So we just learned that this guy here is 2 root 2 times root x. So what does this tell us? This tells us something very, very important to the solution, which is it tells us this. It tells us that the horizontal distance from here to here, that is the horizontal distance from the point of tangency of the blue circle and the black line to the point of tangency of the green circle and the black line. So this distance from here to here is y plus z based on our earlier labels, which is equal to 4 root x plus 2 root 2 root x, which is the same as 4 plus 2 root 2 times root x. Yeah? Cool, cool, cool. Now, there's a bit of mathematical rigor that I'm going to show you on the third triangle of interest, our third and final triangle of interest. Now, before I draw this third triangle, let's first draw its hypotenuse. So the hypotenuse of our third right triangle of interest is going to be this here. Now, what I wanted to be clear is that we shouldn't assume that this line here is going to go through the point of tangency of the biggest circle and the mid-sized circle. That is, we shouldn't assume that this black line, which is about to become the hypotenuse of our third triangle of interest, we shouldn't assume that it necessarily goes through the point of tangency of the blue circle and the green circle. But we can prove that it does. And that's by drawing this line that's mutually tangent to the blue circle and the green circle, wherein we see that this mutual tangent has to be perpendicular both to this radius and this radius. That means that this is one continuous line. Yeah? Okay, cool. So then, those are kind of assumptions that we held to be true earlier in the first 2 right triangles, and I just wanted to point out that we weren't just assuming, it's in fact true. That is, this line does go through that point of tangency right there. Yeah? Okay. Cool. Sorry. All right. Now, let's then go to this right triangle, and this is it. And this is the home stretch. Okay, now, On this right triangle, first observe these things. First, notice that this guy here, this little bit, is 2. Well, then this little bit is also 2. Now, since from here to here is 4, that means that this little bit is 2. Figure not drawn to scale, forgive me. But yeah, this little guy has got to be 2. One leg of the right triangle, the final right triangle of interest. Yeah? Okay, cool. And then we can see that the hypotenuse is 6, right? And then we labored so hard to figure out what this is, this horizontal distance, so the other leg of this final right triangle of interest, and that is this, right? We know that it's equal to this. Okay, so then Pythagorean theorem, once more, as we said, is going to do the job, and all I've done from the previous visual to this is labeled the hypotenuse as 4 plus 2, which as I said is 6, and let's isolate this right triangle and work with it on the Pythagorean theorem. So that first look like this, and then next like this. Solving for x from here is pretty straightforward. Now, you have to do, expanding this and then multiplying by a conjugate after you expand to get to this final answer, but it's all pretty easy algebra. If not, then build up your algebra skills. But yeah, the final answer is approximately 0.69. I hope you enjoyed this and keep watching. Take care.